Okay, girls, let's continue. Now, we have done one of using this indefinite integral rule about complicated function. Let's do another one. A, B, C, D, E, F, G, H. H. Okay, for example, if I have integrating 4 over 6x minus 5 to the power of 3 dx. The first thing we need to do is to convert 6x minus 5 to the power of negative 3. So therefore, now it is exactly the same as before. However, this 4 has nothing to do with your integration. Let's just take it out. And we are integrating 6x minus 5 to the power of negative 3. So that will give you 6x minus 5 to the power of negative 2 because you add 1. And then you need to multiply by negative 2. However, you also need to multiply by whatever number at the front, plus c. So therefore, the bottom becomes negative 12. 4 over negative 12 will give you negative a third. So that will give you negative a third multiplied by 6x minus 5 to the power of negative 2 plus c. And if you want to write it in this way, that's also okay. Remember, they're both correct. I just write this because the question was given in this form. Let's take a look at some advanced question as well. So what happens if I have a question which is x cubed plus 4 to the power of 2? Can we also use the method we did before to just add 1 to the power and divide it by the new power and divide by whatever number at the front? It doesn't work because here, this function here is not linear function. Not linear. So the only thing we can do is to expand it. So that will give us, this is a perfect square, x to the power of 6 plus 8x cubed, a squared plus 2ab plus b squared. Alright? And that is basically what we need to do before. We'll integrate this as the usual way, x to the power of 7 over 7 plus 8x4 over 4 plus 16x, and don't forget plus c. And then give you x to the power of 7 over 7 plus x, 2x to the power of 4, and then plus 16. Oh, it wasn't x before. That's a mistake. Hopefully some of you have spotted it before. Lucky that. Emma, you cannot yell at me today. Next one. So what happens if I have something even more complicated? For example, this is similar to what we got in the textbook. I'll change that. That's 3 minus 1 on x squared, then 3 plus 1 on x squared dx. Okay, this is difference of 2 squared, a minus b multiplied by a plus b. That should give us a squared minus b squared. Okay, and this is exactly like what we did before. However, you might want to change to 1 on x to the power 4 to this, the index form. Therefore, you don't need to worry about the complication. And then you just integrate 9x minus, now this is x to the power of negative 3 over negative 3 plus c. And that will give us 9x plus 1/3 of x to the power of negative 3 plus c, because negative gives you the positive in here. Okay, and if you would like, you can change this back into the fraction form. Again, both of them are correct, so don't worry about that. One is not simpler than another. Okay, now we have done negative indices. So what's the next hard part? Of course, fractional indices. We have talked about this in the definite integral bit. So how do we integrate x to the power of half? Or which is root x. We change this into fraction index. Oh, sorry, ijk. And that gives you x to the power of 3 over 2 divided by 3 over 2 plus c. Now, the easiest way of understanding fraction of fraction is to treat this as your division. So basically, it's x to the power of 3 on 2 divided by 3 over 2. When you divide it by 3 over 2, we just multiply by 2 over 3. Does it make sense to you? Okay, so therefore, we're done. We are done. KL. Next one. What happens if I need to integrate 1 over root x? Now, 1 over means negative. So in other words, we are using our knowledge in index rule, change it back into negative half. Nothing fancy. All you need to recognize is 1 on root x, that is equals to x to the power of negative a half. That's all. And then you perform normal integration on it. So now what we need to do, we add 1 to the power, negative half plus 1 is half, and you're going to divide this by half. And don't forget your plus c once you have finished your indefinite integral. This is very, very important. Now divided by half is just multiplied by 2. So it's just 2 x to the power of half plus c. And if you would like to, change it x to the power of half back into root x. Again, both of them are correct. Let's look at some complicated things. What's that? L, M. What happens if I need to integrate square root of 3x plus 5 dx? Now in this case, it is exactly the same as what we did this one before, but we need to change it into index form. So that should give us 3x plus 5 to the power of not just half, square root it's half, but it's also at the bottom of the fraction that will give us negative half dx. And don't forget, once you've changed into this form, it's exactly like what we did in here. All of these things. All of these things. You use the rule, you need to divide it by the new power, also multiply by the bottom. Multiply the bottom by the first number. Okay, so when you integrate it, it becomes 3x plus 5 to the power of half, because you add 1 to the negative half, give you a new power of half, and then multiply by, divided by the front number 3, multiply by the new power half. Again, plus c. So the bottom becomes 3 on 2. So divided by 3 on 2, that means multiply by 2 on 3. So that becomes 2 on 3, 3x plus 5 to the power of half plus c. Again, you can change this back into square root form if you like. They're both fine. Okay, now let's answer a question we raised before. What happens if I want to integrate something that is not linear inside the brackets with some power? For example, would we be able to integrate this or this? The answer is this is no and this is yes. And I'm going to show you why. Because in 2 unit, there are hard questions, something like this. Here is an example. They will ask us to differentiate something first, and when you integrate the result, you get back whatever before you differentiated. So, like this, first one, they will ask you to differentiate y equals to x squared plus 1 to the power 4. Part B. Then, hence, they will ask us to evaluate something which is the result of this derivative. Integrating 8x x squared plus 1 to the power 3 dx. So let's look at the part A. How do we differentiate y equals to x squared plus 1 to the power 4? And this is chain rule. Chain rule is the derivative inside multiplied by the derivative outside. So the derivative inside in here is the derivative of x squared plus 1, which gives you 2x. And the derivative outside is you bring the 4 down and take away 1 from the power of the whole thing. And that will give us 8x x squared plus 1 to the power 3. And look at this. This is exactly what we need to integrate in part 2. So what does that mean? That means you go one step forward, now you take the step backward. Of course, you end up with the original position. So secondly, if you're integrating 8x x squared plus 1 power 3 dx, and that will simply just give us x squared plus 1 power 4. But don't forget the plus c because it's an indefinite integral, and this is basically from part A. Okay? Now, let's have a quick look of a question something like this. If I ask you to differentiate y equals to 3x squared plus 4 to the power of 5. And the second part I asked you to evaluate, sorry, I'm running out of time, integral of 3x squared plus 4 to the power of 4 dx. Let's see what's the difference between this question and the other one. So dy over dx equals to, remember, it's a chain rule, so you have 6x. That's a derivative of 3x squared plus 4. And then you bring the 5 down, and that becomes 3x squared plus 4 to the power of 4. That will give us 30x 3x squared plus 4 to the power of 4. And the second part in here is we are integrating x 3x squared plus 4 to the power of 4 dx. Unfortunately, this is not exactly the same as what we got in part 1. Or part A, we will make it the same. You can't just change the question, however. You need to multiply 1 on the 30th at the front to balance the 30 we just made up for the result in part A. And in this case, now you can just simply change the question back into what we got before. Because this part will give you this. Okay? Alright, girls. This is all we got today. So please finish exercise 1D. Let's do the whole thing, and I'll check it tomorrow. Alright. Bye-bye.